Okay, so this is the review sheet for chapter 4, and then we've got some review sections from previous lessons that you see there at the top of your review sheet. So let's just get right into the solutions to these problems. So for number 1, I'm going to see if you understand and know how to utilize, how to use the properties of exponents to simplify an expression. So what I always like to do for these problems is simplify as much as I can in the parentheses first, this fraction that's in the parentheses. So that begins with simplifying 6 over 24. So 6 over 24 is 1/4. All right, and the way I simplify variables that are being divided, for like variables, I subtract their exponents. So that's x to the second divided by x to the fourth, that's x to the 2 minus 4 power. And so that's going to be, for now, it's going to be x to the negative 2. Notice that I just keep that on the top. So once you do the simplifying, combining the two variables into one, it will start up on the top of the fraction. And then do the same thing for the y's. Y to the 5 minus 2 power is y to the third. And all of this is still, it still needs to be raised to the third power. Okay, so now everything that's being multiplied, every separate term within this fraction needs to be raised to the third power. So 1 raised to the third is still 1. When I raise x to the negative 2 to the third, it becomes x to the negative 6. Whenever you have a power that's raised to another power, a power inside that's raised to a power outside, that's when you multiply those powers together. And in a similar way, this becomes y to the ninth. And then don't forget, you also have 4 down here at the bottom. It needs to be raised to the third power. 4 to the third is 64. Okay, so the only thing that needs to be changed before I get to my final answer is you never want to leave a negative exponent in an answer. So all we have to do to fix this is make this become x to the positive 6 in the denominator. So just move it down to the bottom, and then you can change the power. So the final answer, I'll just put that answer so we can squeeze it in down here. This is going to be y to the ninth in the numerator over 64 x to the sixth. And that ends up being your final answer for number 1. Okay, number 2 is similar. Let's see what we can simplify within this fraction first, and then we'll raise everything inside to the negative 2 power. So that's just 5, just going to rewrite the 5. I'm going to combine the two a's. So once again, there's that rule of division of like bases. You subtract the exponents. So that's going to be a to the negative 7 minus 1 power, that's negative 8 power. And b is going to be the 2 minus negative 6 power, which is b to the positive 8. And everything still needs to be raised to the negative 2. So 5 is raised to the negative 2. When I raise a power to another power, there's that rule again, you multiply those powers together. So that makes a to the 16th. And this makes b to the negative 16th. So the negative exponents need to be changed. This a has a positive exponent, so it's going to stay on the top of the fraction. And in the bottom of the fraction, I'm going to do 5 to the second power, which is 25. So move it down to the bottom and then change the exponent to positive. And the same thing for the b term. It's going to move down to the denominator, and its exponent will also become positive. So there's my answer for number 2. All right, so for number 3, the first thing I need to do here before I can, this all means to be multiplied together. But according to PEMDAS, before you multiply, you have to take care of exponents. So the first thing that has to happen is I need to raise both a and b, this product, to the negative 5 power. So I'm just going to write everything else, just bring it down. Okay, and this is where I'm going to raise a to the negative 5, and then I'm going to also raise b to the negative 5. Okay, well, let's multiply coefficients first. So obviously I have 2, there's an invisible 1 here, 2 times 1 is still 2, and there's an invisible 1 here, so still 2. 2 times 1, that's just 2. And now the rule of multiplying, when I'm multiplying bases that are the same, like these two a's, I add the exponents together. So it's going to be a to the 3 plus negative 5 power, and that makes negative 2. And it's going to be b to the 2 plus negative 5 power, which is negative 3. So I got 3 terms here, 2, a to the negative 2, b to the negative 3. And the ones, just the ones that have negative exponents need to be changed. 2 does not have a negative exponent. It's got an exponent of positive 1. So 2 is staying put, but in the denominator of this fraction, I'm going to write this as a to the positive 2, b to the positive 3. And that's my answer for number 3. All right, let's scroll down and we'll take a look at the next problem. Okay, so for number 4, we're going to expand this binomial using your method of choice. And what I mean by that is you can either use Pascal's triangle. So let me just go ahead and do Pascal's triangle. So start off with a 1, follow that up with 2 1s, and then you begin your pattern of adding. 1 plus 1 is 2. Every row starts and ends with 1. 1 plus 2 is 3. 2 plus 1 is 3. And the row that we need would have 5 numbers. Remember, when you expand a binomial like this, you should end up with one more term than what the power of the problem shows. So I should end up with 5 terms. Well, this row only has 4 numbers on it, so I need one more row. 1, 4, 6, 4, 1. So this is the row of the triangle that I would use if I'm using Pascal's triangle. So it works like this. I use the first number from the triangle times, then I take the first term in the parentheses and I'll raise it to this outside power. And the second term in the parentheses, negative 3, starts off at the 0 power. All right, next number from the triangle is 4. M now drops down and negative 3 goes up. And I'll come back and simplify all that in just a minute. Next number from the triangle, 6. M goes down, negative 3 goes up. Next number from the triangle is 4. M goes down, negative 3 goes up. And then finally, the last number from the triangle, 1. M goes all the way down to the 0 power, and negative 3 goes up to the 4th. And now to simplify this, my first term will be simplifying all of this. Negative 3 to the 0 power is just 1. So 1 times m to the 4th. That's my first term. Here's my second term. Negative 3 to the first is negative 3, and negative 3 times 4 is negative 12 m to the 3rd. Okay, simplifying this will give me the third term. Do the power first. Negative 3 squared is 9. 9 times 6 is positive 54. M to the 2nd. Okay, the fourth term, I'll do this. Negative 3 to the 3rd is negative 27. And negative 27 times 4 is negative 108 m. And then the fifth term, simplify this. 1 times 1, m to the 0 is just 1. And negative 3 raised to the 4th power is positive 81. So that would be if you chose to use the triangle. The only difference is if you wanted to use the binomial theorem, you would, instead of using the triangle for these coefficients, 1, 4, 6, 4, 1, you would use combinations. So let me just, if somebody did choose to use the binomial theorem, your answer would look like this. You would start with 4C0, and then you would do the variables just like we did with the triangle, m to the fourth, negative 3 to the 0. Everything else would look just the same, but you're going to calculate these numbers using combinations instead of just pulling them from a particular row in the triangle. Okay, so I'll just kind of get this started, and you can see everything else is the same. Well, that should be first. So everything else is the same, except just instead of looking at 4 and taking that number from the triangle, you're going to calculate 4C1 in your calculator. And I'll just do one more. So to get the next term, it should be 6, but you would arrive at that by doing 4C2. So you're welcome to use the binomial theorem on the test, but you would just need to show me this kind of work. And I'll just go ahead and finish it out. 4C3 would be the next. And then finally 4C4. M has gone down to the 0 power, which is just 1. And all these are just being multiplied together, just like you did before. Everything's the same. It's just a different way of coming up with these coefficients. Same answer. Okay, number 5, we want to get the 7th term of the expansion. So this is only one of the terms in the binomial theorem. So the way I can do just the 7th term is by calculating, take the exponent in your problem, 8, and this is going to be a combination, so it's going to be 8c, and whatever term you're asked to find, just make this number that follows c one number less than that. So I'm looking for the 7th term. This will be the 6th, but the number 6. And if you think about it, it makes sense, because notice when you expand with the binomial theorem, you always start at 4C0. So by the time you get to the 7th term, if you start at 0, this number would be 6. Okay, so it's always one number less. And then we're going to multiply, just take the first number inside the parentheses, 2a, first term, and it's going to be raised to the difference between these two. 8 minus 6 is 2. And then we'll multiply that, second term in the parentheses, negative 2b. And just remember, in the binomial theorem, you can kind of see it up here. Notice how the number after c and the second exponent will always be the same. That's always true when you do the binomial theorem, and that's really what we're doing. We're just pulling out one term of it. So if you remember that, the number after c and the second exponent of the expansion should always match. Okay, and then you go to your calculator, and you would calculate 8c6. So I'm getting my calculator here. 8c6. And that's 28 times, this would be 4a to the second. And this would be negative or positive 64b to the sixth. When you raise a negative number to an even power, it becomes positive. And now we just have to multiply all this together to get our final answer. So 28 times 4 times 64 is 7168. And our variables are a to the second, b to the sixth. And that's the answer for number 5. Okay, let's scroll down and we'll take a look at the next few problems. So number 6 is another binomial theorem. We call it the binomial probability. A pitcher is just as likely to throw a ball as a strike. So that means we have a 50-50 50% throwing a ball, 50% throwing a strike. So I'm just going to write down the two possibilities. There's always two possibilities that add up to 100% for these binomial probability problems. So we're supposed to find the probability that 12 of her first 15 pitches are strikes. So I'm just going to call this strikes, and I'm going to raise it to the 12th power. That's what the problem wants to know. If 12 are strikes, just raise that strikes percentage to the 12th. And if she threw 15 pitches, 12 were strikes, that means 3 had to be balls. All these are being multiplied together. It's just, again, just like we looked at in the previous problem with the binomial theorem, all this is multiplied together, and now we have to come up with a combination factor. So the total number of whatever the activity is will be to the left, in this case 15 pitches. And remember what we said earlier in a previous problem, this number, the second exponent, and the number after C should always be the same. And now you just go to your calculator, and once again you're going to do 15C3 this time. 15C3, and that's 455 times, I'm just going to write it all out. You could just do all of this in your calculator at once, but I'll just show you what each number is separately. 0.5 raised to the 12th power. It's a long decimal, so I'll just read it off to you so you'll know what it is. It's 0.000244140.625. So I think I will just go ahead and multiply all this together. And then 0.5 to the third. So your final decimal answer is 0.013885498 and so forth. But remember, that's a decimal, and we want your answer in percent. So if you want to, you can multiply that decimal times 100, or you could just slide the decimal 2 places to the right. And we're told to round to the nearest hundredth. That's 2 decimal places. So to the nearest hundredth, that's going to be 1.39%. And that's your answer for number 6. All right, let's do some long division. So number 7 sets up like this. We divide x minus 2 into 2x to the third minus 7x squared plus 7x minus 2. Okay, so for long division, the first term, in this case x, divides into the first term, which is 2x to the third. So I notice some people are doing this on their quizzes and tests and homework, and I think it's a good idea if it helps. So really you're just doing 2x to the third divided by x. So just think about what that would be if you simplified this fraction, and that would be 2x to the second. You subtract exponents when you're dividing. And now that you found how many times x goes into 2x to the third, you multiply that by both of these terms. So 2x to the second times x, and 2x to the second times negative 2, that's negative 4x squared. And with long division, you always subtract, so you have to keep that separated from synthetic division, which is addition at this point. Okay, so the x cubes will cancel, so be careful here. Negative 7 minus negative 4, so subtracting a negative is really plus, so that makes negative 3x squared, and then bring down the next term. Now you're dividing x into negative 3x squared, so it looks like this, negative 3x squared divided by x, and that's negative 3x. And multiply negative 3x times both of these, negative 3x squared plus 6x, subtract, The x squares will cancel. 7 minus 6 is 1x minus 2. And you can see at this point, it looks like we're not going to have a remainder. X divides into x one time. And then multiply times both. And we end up with a 0 remainder, so this ends up being my answer. All right, let's try another one. This time we're dividing by a trinomial. So we'll set this up. Be careful that you don't skip over exponents. Always be aware of that. We started at x to the fourth. We do have an x to the third. We have x to the second. We have x, and we have a constant. So no need to fill in a missing 0. All right, so divide first term into first term. X squared into x to the fourth is x squared. And multiply. X squared times x squared. X squared times negative 5x. X squared times 4. Subtract. X to the fourth cancel. Negative 4. Now this is going to be plus 5. Negative 4 plus 5 is 1. X to the third. Negative 7 minus 4 is negative 11. X squared, and then bring down the next term. Okay, now you're dividing first term, x squared, into first term, and that's x. I left off x here, sorry about that. So x times x squared is x cubed. X times negative 5x is negative 5x squared. X times 4 is 4x. Subtract. X cubes cancel. Negative 11 plus 5 is negative 6x squared. 34 minus 4 is 30x. And bring down the last term. And let's go one more time. X squared into negative 6x squared is negative 6. Multiply negative 6 times all three terms. Squared plus 30x minus 24. And once again, we have a 0 remainder. So this ends up being our final answer. Okay. Next three problems. Identify the end behavior of the graphs of each function. And we're used to looking at the graph itself and being able to just write down what the end behavior is, but how do we do it if we're not looking at the graph? So remember lead coefficient. Okay, so it really works out this way. I'll just do it with this little diagram. The lead coefficient will tell us what happens on the right. Okay, lead coefficient positive, it's going to go up on the right side, negative, down. Okay, the degree will tell us about the left side. And remember, the easy way to remember that is for odd degree, it's going to be the opposite of the right side. Okay, so let's just take a look. All right, so look at the lead coefficient, and we'll take care of the right side first. So the lead coefficient is negative. So that means that I'm going to describe the right end like this. As x approaches positive infinity, that's moving to the right. Since the lead coefficient is negative, that means it's going down on the right. The function is going down. Okay, now the degree of the polynomial is the highest exponent of x, which is 3. That's an odd number, so it should do the opposite on the left side. Okay, so this is left, this is right. So now let's describe the left. As x approaches negative infinity, that's the left, it should do the opposite of what it did on the right. So it's going to go up. All right, there's my answer for number 9. So number 10, look at the lead coefficient. It's positive. so it should go up on the right as x approaches positive infinity. It's going up, positive infinity. Okay, the degree is even. So if odd means opposite, even must mean the same. As x approaches negative infinity, going to the left, it's also going up there as well. Number 11, the lead coefficient is negative, so it's going down on the right. As x approaches positive infinity, that's the right side, it should be going down, negative infinity. And the degree is even, so it should do the same thing on the left. Same degree, or even degree going in the same direction. As x approaches negative infinity, the function's going down. Okay, so odd, notice opposite, even degree, same. Even degree, same. Lead coefficient, negative, down on the right. Lead coefficient positive, up on the right. Negative, down on the right. Okay, so if you'll just make sure you remember this, we've talked about this in the past, you should have it in your notes. Just go back and review that for your test. Okay, and the next problem is substitution. If the function d of x is described in this way, here's my function d of x, then what do we get if we input 4a squared? So d of 4a squared literally means wherever there's an x in the function, it's going to be replaced with 4a squared. So every x in the function gets replaced. And now we simplify, okay? So you do powers. This is like multiplying by -1, so notice the x itself is being raised to the -3rd, not negative x. Okay, so when I do this, it's like 4 to the 3rd times a squared to the 3rd. That's 64. 4 to the 3rd is 64, a to the 6th. And then I'm going to multiply that by -1, and it's going to turn it into -64, a to the 6th. And there's really nothing else to do other than just write these terms down. The only calculation had to occur right here with this first term, so that ends up being our final answer. Just whatever you're given as the input, make sure you replace the variables, however many variables there are, replace all of them with this input, and then simplify. Okay, 13 is or 13 through 15, they're all factoring problems. So this is an example of the difference between two perfect squares. So hopefully you remember how to factor those. The square roots, a squared and 4, and really twice, and make one of them plus and one of them minus. And I have that situation again here. You don't have to worry about factoring with the number I, okay? So the only other difference, the difference between two squares can be done here. I'm just going to bring this down. And so factoring the difference between two squares, that would be a +2 times a -2. And that is considered to be fully factored. All right, number 14, just a reminder that when you're factoring, always look for a GCF first, and there is one. You can divide both of the numbers by 2, and you also have common variable y. So when we factor out 2y, we got 27x to the 3rd minus 8y to the 3rd. Now within the parentheses, we have that special case of the difference between two perfect cubes. So bring down the 2y, it's still part of the factoring. So go back and review, if you haven't already, how to factor the sum and the difference, because on the test this might be plus, so make sure you know both. The difference between two cubes, we find the cube roots. 3x is the cube root of the first term, and 2y is the cube root of the second term. Then we make a trinomial factor using these two cube roots. So the first term in the trinomial will be 3x squared. 3 squared times x squared, so that'd be 9x squared. Then we follow that up with plus, and we multiply these together. That's 6xy. And then we do plus 2 squared times y squared. That's 4y squared. And that's my answer for number 14. Make that a little bit plainer here on the end. Okay, number 15, I just want to know if you can do factoring by grouping. So this sets up really nicely the first three terms. Have a GCF, and that would be y, and the next three have their own GCF, and that would be z. So you're going to set up two different groups of three, and with each group of three will have its own separate GCF. All right, so factor out y from the first three, and that's 6a, actually 2y, sorry, because you can divide 2 into each one of these. All right, so 2y divided into 6ay is 3a, and then 2y divided into 4by, that's 2b, and then 2y into negative 2cy, that would be c, minus c. All right, and then we're going to factor out z, and we're hoping that when we do, we're going to get the same result in this set of parentheses, and that tells us that we've done the correct factoring. It's set up correctly. All right, so when you divide z into 3az, you get 3a. So far, so good. Z into 2bz, that's 2b. All right, and then z into cz, negative cz, that's negative c. So the final answer will be put the two terms that are currently not in parentheses together, and that represents a factor, and then the matching parentheses will be the other factor. All right, we are moving right along. The next problems are solving problems, but we're going to use factoring in order to help us solve. So for number 16, I noticed that there is a GCF. I can factor out x, and it makes it become x squared plus 2x minus 35. And I notice in the parentheses it's a trinomial where the factors of the last term add up to the factor in this term in the middle. The factors of the last term add up to the term in the middle. So hopefully you recognize that 7 times negative 5 equals negative 35, and 7 plus negative 5 equals positive 2x. So x plus 7, x minus 5 is going to be my factoring. And so I'm looking for 3 solutions altogether. So just take each of your separate factors, set them equal to 0, and that will help you with your solution. So 0, negative 7, and positive 5. All right, for number 17, looking for a GCF. I don't see one. So it's a trinomial. So I wonder, since this number in front of x to the fourth is bigger than 1, if we can factor using the box method. So we can if, let's just go ahead and do the first and the last multiplied together. That's 24x to the fourth. Are there factors of 24x to the fourth that add up to negative 10x squared? And hopefully you see that that would be negative 6x squared and negative 4x squared. Okay, so factoring is possible. And I also know that the signs of my factoring are both going to be negative. Negative in front of positive means both of these are negative. So let me just set up the box down here and we'll come up with the exact factoring. So 8x to the fourth, since we already know what the signs are, don't worry about putting signs in the box. We already know what to put here. Doesn't matter where they go. And now just find your GCFs. So this would be 2x squared and 1. And this would be 4x squared and 3. Okay, so you could double check it and make sure if you do FOIL, are you going to get this trinomial? And it looks like we are. So since you've already seen the box method and I need some room to solve, I'm just going to erase the box. But that was just a little box method review. So take each of your separate factors and make them equal to 0. So 2x squared equals 1, x squared equals 1/2, x equals plus minus the square root of 1/2. And later on, we're going to talk about rationalizing denominators. That just means that we're not supposed to have a radical in the denominator of a fraction. And this one does, but since we haven't covered that yet, I'm not going to worry about that on the test. So I'm going to say it's okay for now to leave radicals in the denominator. If you know how to do it from Algebra 1 or from geometry, that'd be great, but I'm not going to require it on this test. So this answer would be fine for now. All right, and so here we have solving for x. Here we have plus minus. This would be the square root of 3. Just do the square root of each number separately over 2. Okay, so we were looking for 4 solutions. 2 of them are here, positive root 1/2, negative root 1/2, and then here are the other 2. All right, and then finally, this is once again the difference between 2 cubes. So let's factor it as 2x minus 3, and then 4x squared plus 6x plus 9. Okay, let each of your factors equal 0. So if you let 2x minus 3 equal 0, you're going to get x is 3/2, just to save a little bit of space. So just treat that like an equation, 2x minus 3 equals 0, and then solve for x. For this one, we've talked about these. You'll probably want to use the quadratic formula. I think that will be the easiest thing. So hopefully you remember that. The opposite of b plus minus square root of b squared minus 4 times 4 times 9. 16 times 9, that's 144, all over 2 times 4. This is the square root of negative 108. And when we simplify this radical, let me just come up here. The square root of negative 108, obviously it's going to have the number I. And I'm going to use 36 and 3, root 36 and root 3. So that makes 6I root 3. And then I think I'll put my final answer up here because notice we can reduce. You can divide by 2 into these numbers that are not under the radical. So negative 3 plus minus 3I root 3 all over 4. And that goes along with 3/2 as my final answers. Okay. Now we'll do a synthetic substitution problem. Okay, so for synthetic substitution, let's take -2 first, put it in the house, and then beside that we're going to put 1, 4, -3, +2, and whatever we get as the remainder will be the answer. It will be the output. So bring down the first number, -2, +2. 2 times -2 is -4, it's -7. 14 plus 2. So my answer for input -2, when I substitute -2, I should get output 16. Now I'm going to do the same thing with 4. 1, 4, -3, 2. Bring down the 1. 1 times 4 is 4, and that makes 8. 32, and that makes 29. 29 times 4 is 116. And when you add 2, you get 118. So that's my answer for input 4. Substituting 4 in for x should give you 118. And you could check this using old-fashioned direct substitution if you like, if you have time on your test to make sure that you did it correctly. Okay, this is number 20 is an example of what we call the factor theorem. This is really the remainder theorem. And so the factor theorem says I'm going to give you a factor, x plus 5, and now let's find the other remaining factor. So we're going to use synthetic division. So if you were dividing by x plus 5 using synthetic division, that means you would put -5 in the house. And then to the right of that, you're going to put 3, 20, 23, -10. Make sure you don't jump over exponents. Now, theoretically, I should get a 0 remainder when I do this. So let's see. Bring down the 3, -15, that makes 5. -25 makes -2. 10, -10. Okay, so works out. So these numbers, since I divided into third degree, these numbers represent a second degree polynomial. And we want to see if we can factor this, and if we can, that will be the remaining 2 factors. So again, you might want to use the box method as your factoring method. So 3x squared -2, that's -6x squared. And the factors of -6x squared that add up to +5x would be 6x and -1x. And now you find your GCFs, 3x and -1. So that's one factor. And then x and 2, x plus 2, will be the other factor. All right, and so this represents the final answer. Okay, finding the zeros. So this is the rational root theorem and synthetic division. So my potential possible rational zeros are all the factors of 6, ±1, ±2, ±3, and ±6. But if you notice, we talked about in class how there sometimes is a special pattern that presents itself, and it really gives us, it saves us a lot of time in looking through all the possible zeros to find the actual one. So whenever the coefficients multiply together and it equals the constant, 1, 2, 3, 1 times 2 times 3 is 6, then you know that for these cubic polynomials, the 0 is going to be the opposite of whatever is in front of x squared. So I know that -2 should be one of my rational zeros, so I don't have to go through all 8 possibly to find out what it is. So this is synthetic division again. So we should get a 0 remainder. Let's see if we do. -2 plus 2 is 0. 0 plus 3 is 3. -6 plus 6 is 0. Okay, sure enough, -2 is one of my 3 answers. And then these numbers represent x squared plus 3 equals 0. And when I solve this, then we will have our other 2 solutions. So x squared is -3, so x is plus minus I root 3. So that represents 2 solutions, and then -2 is my third. Okay, so let's try this one. Again, if we use the rational root theorem, we'll come up with all the possible rational roots. So just think about all the factors of -100. Plus minus 1, plus minus 2, plus minus 4, plus minus 10, plus minus 25, minus 50, plus minus 100. Wow, a lot of choices. So let's go through our synthetic division and we'll see if we can figure out which one actually works. Gives us a 0 remainder. 1, -3, 21, -75, -100. So I usually just start small. I'll start with +1. 1 times 1 is 1, plus -3 is -2. -2 plus 21 is 19. 19 plus -75 is -56. And -56 plus -100 is -156. So 1 isn't going to work, so we'll just try -1. -1 plus -3 is -4. 4 plus 21 is 25. -25 plus -75 is -100. +100 plus -100 is 0. Okay, so we know that one of my zeros is -1. So now I'm going to take the numbers, I've got it down to 3rd degree with these numbers. Well, now we're going to go through the table again, but if you notice, our special pattern has presented itself. So that's going to be a big time saver because 1 times -4 times 25 equals -100. So I must have a 0 of +4. All right, bring down the first number. 4 plus -4 is 0. 0 plus 25. 100 plus -100 is 0. Okay, and now I just have to solve this quadratic, x squared plus 25. And so subtract 25 from both sides. And my final 2 zeros are going to be plus minus 5i. All right, so that takes care of 22. The review of section 04, we're interested in knowing if you understand how to use the fundamental counting principle. So that's on number 23. A bike shop sells bicycles that have 2 different speeds, 5 colors, and 4 sizes. So how many different bike options are there available for sale? You basically just take the total of each different category and very simply just multiply these together. And so the answer to number 23 would be there are 40 different bicycles available for sale. Okay, number 24, we have this health food store. They offer 10 toppings for yogurt. And the question is how many different 3-topping yogurt sundaes can be formed with the 10 toppings, assuming no topping is used twice. So this is an example of a combination, and the question always comes up, well, what's the difference between a combination problem and a permutation? Permutation is all about how many different ways we can put things in a certain order. Well, the order of the toppings is irrelevant. We just want to know how many different 3-topping yogurt sundaes can we make out of 10 toppings. So you can go to your calculator, and 10 is the total number of toppings, and we want to know how many different 3-topping sundaes we can make. So we just go to our calculator and we do 10C3. See what that number is. And that's 120. There are 120 different 3-topping yogurt sundaes. Okay, the next problem is a good example of a permutation. In how many ways can a president, vice president, secretary, and treasurer be elected from a club with 15 members? So if you think about it, this is a ranking, this is an order. President is first, vice president is second. There's no way for a person to be both president and vice president. So you have a first, and it's kind of like a first, a second, a third, and a fourth in the ranking order. So for permutations, you again take the total number, 15, and we've got 4 different places to fill, 15P4. So let's go to our calculator and calculate this. 15 in PR4, and that ends up being 32,760. Oh, wrote it in the wrong place. Okay, 26 is a review problem. Just making sure you understand that parallel lines have the same slope. So the slope of this line is 4. So the slope that I'm going to use for this other line that passes through 10, 2 is also going to be 4. So just remember y equals mx plus b, slope-intercept form. So y is 2. The slope we're going to use is 4. X is 10. And we'll use this to solve for b. So b is going to be negative 38. And so my equation, y equals 4x minus 38. That's the answer for 26. For 27, you're given a quadratic function. You have to find the discriminant, and this is how you do it. Just take out this part of the quadratic formula, just the part that would be under the radical. So in this case, that would be b is negative 3, so b squared is 9. A is 2. And c is negative 4. So when we calculate this, we have 9 minus, and make sure you multiply all these together. 4 times 2 is 8, and that's 8 times negative 4 is negative 32. So the discriminant is positive 41. So how many x-intercepts are there on the graph? Well, just remember, a positive discriminant means I've got 2 real number solutions, which also means I have 2 x-intercepts. So that's my answer for letter B. If this had been negative 41, I would have no x-intercepts. And if it had been 0, I'd have 1 x-intercept. So now let's solve using the quadratic formula. So the opposite of B, plus minus, and we've already done the discriminant, so it's a square root of 41 all over 2 times 2, which is 4. You can't simplify the square root of 41, so and I just want you to leave your answer in exact answer form. So that is your answer. Okay, number 28, the equation for the axis of symmetry. Well, the formula to find the axis of symmetry is opposite of b over 2a. Okay, so our b number is -4, and then 2 times a is 1. So in the parentheses, this would be -2. -4 divided by 2 is -2, and the opposite of -2 is +2. So the answer for letter A, and it's an equation of a vertical line, it's going to be x equals 2. What is the vertex? Well, to find the vertex, just take the AOS number and plug it in, or in other words, think of f of 2. 2 squared minus 4 times 2 plus 7. You're just going to use the AOS number as an input and see what comes out. So -4 plus 7 is 3. So the x-coordinate of the vertex will be the AOS, and the y-coordinate of the vertex will be this output. So the vertex will be the point 2, 3. Does the function have a maximum or a minimum? Well, it depends on how it opens, and if you notice, the number in front of x squared is positive, so this parabola has to open up, and the point 2, 3 is at the very bottom of it if we just did a rough sketch. So since the vertex is on the very bottom of the parabola, we have a minimum. And the value is always whatever the y-coordinate of the vertex is. So in this case, it's going to be 3. Okay, that takes care of number 28 and the last two. So for number 29, we're going to do FOIL. 3 times 4 is 12. 3 times 3i is 9i. 4 times -2i is -8i. And the last terms together would be -6i squared. Well, you always have to keep in mind that I squared is equal to -1. So anytime you write down I squared, you need to replace it with -1. So I'm going to combine like terms here. 9 minus 8 is 1, positive 1i. And if you treat I squared as -1, this is like -6 times -1, which makes positive 6. And now you can add the two real numbers together. And when you're writing these complex numbers, always make sure you write the real number first. And then I will be second. So there's the answer for 29. Number 30, I'm going to change the square root of -25 into 5i. Then I can multiply these together. That makes 30i. And now I'm just going to put it in complex number form. The proper form for a complex number is the real number goes first, followed by the imaginary number. And that's it. That is the conclusion to this review sheet, and I hope this helps you as you prepare for your test. If you have any questions, let me know.